Hello everyone, welcome back. In previous lecture of mechanical measurement and metrology, I explained about the errors in measurement and what is the difference between precision and accuracy. So precision is nothing but the repeatability of measurement value, while the accuracy is amount by which we get the measured value near to the true value, okay, as close to the true value as possible. Now, in today's lecture, uh, we will start with the development of material standards, and which means जो material standards थे वो कैसे डेवलप हुए उसके बारे में डिस्कस करेंगे. Now, the need for establishing a standard of length was raised primarily for determining the agricultural land areas and for erection of buildings and monuments. The earliest standard of length was established in terms of parts of human body. The Egyptian unit was called as a cubit, and it was equal to the length of forearm. So from the elbow to the tip of middle finger. Okay. Now the rapid advancement made in engineering during 19th century was due to improved material available and more accurate measuring techniques developed. And it was not until 1855 that the first accurate standard was made in England, and it was known as Imperial Standard Yard, the first standard, that was Imperial Standard Yard, and this was followed by International Prototype Meter. After that, there was International Prototype Meter in the France in year 1872. Now, these two standards of length were made of material in which the material was basically metal alloys, and hence they are called as material standard. That is why they are called as material standard, in contrast to wavelength standard adopted as length standard later on. मटेरियल स्टैंडर्ड को फिर किसने रिप्लेस किया? वेवलेंथ स्टैंडर्ड से. ठीक है, फिर वेवलेंथ स्टैंडर्ड में लाइट का यूज किया गया. ठीक है, टू डू दी मेजरमेंट्स. ओके. Now, this is about the development of material standards. Now, the first standard is Imperial Standard Yard. Now, the Imperial Standard Yard is made of 1 inch square. So, there is 1 inch square cross section of bronze bar. The bar is made of bronze. Okay, and there is 82% copper, 13% tin, and 5% zinc. So it is made of a bronze bar, and it is 38-inch long, and the bar has two 1.5 inch diameter and 1/2 inch deep hole. Each hole is fitted with 1/10 of inch diameter gold plug. There is one gold plug, and the top surface of these gold plugs lies on the neutral axis of bronze bar. So here you can see in the Imperial standard they are made of 1 inch square cross section. The size is 1 inch over here you can see, and they are made of bronze bar 38 inch long. Now they are having 1.5 inch. Here you can see this is the gold plug, and each hole is fitted a 1/10 inch diameter gold plug. Okay, 1/10 inch diameter gold plug is fitted. The top surface of these gold plugs lies on the neutral axis of bronze bar. Here you can see the top surface lies on the neutral axis. The purpose of keeping gold plug lines at neutral axis has some advantages. So by keeping the gold plug line at neutral axis, we can have following this advantage. The first advantage is due to bending of beam, the neutral axis remains unaffected. When the if there is bending of beam, okay, so then the neutral axis will remain unaffected, and the plug remains protected from accidental damage. If there is any possibility that the plug can get accidentally damaged, but here they are inserted in the deep groove, so there are less chances of accidental damage. Another advantage is that the top surface of gold plug is highly polished and contain three lines engraved transversely and two longitudinally. Here the gold plug is highly engraved, and this is the enlarged view of gold plug showing the engraved. Okay, so it is having three lines engraved transversely and two lines longitudinally. Okay? There will be three lines in the transverse direction, which means in the this direction, while in longitudinal direction it will be having the two lines. Okay, the yard is defined as the distance between two center transverse lines on the plug when first the temperature of bar is 62 degree Fahrenheit, and second thing, the bar is supported on rollers in a specified manner to prevent flexure. Okay, so ये 1 yard हम कैसे डिफाइन करेंगे? द डिस्टेंस बिटवीन द सेंट्रल ट्रांसवर्स लाइन. ओके, दिस सेंट्रल ट्रांसवर्स line, that is will be called as 1 yard. Okay, from this distance to this distance. Okay, another it will be called as yard, and there will be specific 62 degree Fahrenheit temperature is required. Moving further, the second type of standard is international standard meter, or it is called as prototype standard, or you can see here the how the international standard section looks like. Now this standard was established originally by International Bureau of Weights and Measures in the year 1875. This IBW is IB is very much famous in International Bureau of Weights and Measures. You might have heard about it. In 1875, they developed this international standard meter. The prototype meter is made of mainly platinum iridium alloy, which is containing 90% platinum and 10% iridium, having a cross section. Here you can see in this figure, it is having a ruled line on the neutral plane of bar with graduation on this surface. This surface is particularly graduated, and using this surface we can measure the 1 meter. So this is the meter standard. Earlier was about the yard. The upper surface of web is highly polished and has two fine lines engraved over it. This is the upper surface is highly polished and it is having two lines engraved in it, and it is in inoxidizable and can have a good finish required for ruling good quality of lines. Okay, the bar is kept at 0 degree centigrade and under normal atmospheric pressure. It is supported by two rollers of at least 1 centimeter diameter, symmetrically situated in same horizontal plane. Okay, so there will be two supporting rollers are there, symmetrically situated in the same horizontal plane. The distance between the roller is kept 589 mm so as to give the minimum deflection. The web section chosen gives the maximum rigidity and economy of costly material. The distance between center's portion of two lines engraved on the polished surface of this bar of platinum iridium alloy is taken as 1 meter. So this is how we consider 1 meter. This is the two lines engraved on the polished surface of bar, and the distance between them is taken as 1 meter. According to this standard, the length of meter is defined as straight line distance at 0 degree centigrade between center portions of pure platinum iridium alloy, which means 90% platinum and 10% iridium, of 102 centimeter total length, and having a web cross section as you can see in the figure. Okay, so this is about the international standard meter. Now there are certain disadvantages of material standard. As we have seen, the material standard, the material standard are influenced by effects of variation of environmental conditions like temperature, pressure, humidity, aging, and thus its changes in length. What happens with the material standard? They are made of certain materials, so there will be effect of environmental conditions. Another disadvantage is that these standards are required to be preserved or stored under security to prevent their damage or destruction. As they are physical standards, so they are required to be maintained very safely. A replica of these standards was not available for use somewhere else, as the materials are very costly, so replica were not available, and these are not easily reproducible. As you can see, the accuracy in required in these standards for making them is very much high, so it is not possible to reproduce them. Then conversion factor was to be used for changing over metric per. Suppose if we have yard standard, then we have to convert the yard into meter. Considerable difficulty in is experienced while comparing and verifying size of gauges. Okay, so it is very much difficult to compare with the size of gauges, as you can see the complex shape of the standard. So this is about the material standards. The next standard which came later on is wavelength standard. The major drawback with the metallic or material standard like meter and yard is that their length changes slightly with the time. Secondly, considerable difficulty is experienced while comparing and verifying the size of gauges by using material standards. So there is difficulty in comparing and verifying size of gauges. As we have seen, these are the major two drawbacks of metallic or material standards. These lead to error of unacceptable order of magnitude. If therefore become necessary to have a standard of length which will be accurate and invariable. So the Jacques Bennet, a French philosopher, suggested that wavelength of monochromatic light can be used as natural and invariable unit of length. So what he suggested, to use a monochromatic light, as that can be used, the wavelength of that can be used to measure the length. Okay, now in 1907 the international angstrom unit was defined in terms of wavelength of red cadmium in dry air at 15 degrees centigrade, which was 6438.4696 angstrom is equal to 1 wavelength of red cadmium. 7th General Conference of Weights and Measures approved in 1927 the definition of standard of length relative to the meter in terms of wavelength of red cadmium as an alternative to the international prototype meter. Okay, so the 7th General Conference of Weight and Measure, they approved the in 1927 the definition of standard length relative to meter is in terms of wavelength of red cadmium. Remember this, wavelength of red cadmium. Orange radiation of isotope krypton 86 was chosen for new definition of length in 1960, and by the 11th General Conference of Weights and Measures, the committee decided to recommend that the krypton 86 was the most suitable element and that it should be used in a hot cathode discharge lamp maintained at temperature of 63 degree, 63 Kelvin. Okay, so degree will not come over here. Now the krypton 86 isotope was most suited for this wavelength measurement. According to this standard, meter was defined as equal to 1650763.73 wavelengths of the red orange radiation of krypton isotope 86 case. The this was equal to 1 meter according to this standard. The standard as now defined can be reproduced to an accuracy of about 1 part in 109. So we can reproduce it easily with accuracy of 1 part in 109. The meter and yard were refined in terms of wavelength of orange krypton isotope, that is krypton 86 radiation, as 1 meter is equal to this much wavelength, and 1 yard is equal to 0.9144 meter multiplied by this wavelength. So we will get the answer in terms of wavelength. So 1 yard is equal to 1509458.3 wavelengths. So this is about the wavelength standards. Now meter as today. How we measure meter now? Although the Krypton 86 standard served well technologically, increasing demand more accurate standard. Now the demand increased for to having more accurate standards. It was through that a defined based on speed of light would be technically feasible and practically advantageous. Now the 17th General Conference of Weights and Measure so agreed to a fundamental change in the definition of meter on 20th October 1983. Okay, so the 17th Conference of Weight and Measure agreed on the fundamental change in definition of meter on 20th October 1983. Accordingly, a meter is defined as a length of path traveled by light in a vacuum in 1 by 299,792,458 seconds. And this can be realized in practice through the use of an iodine stabilized helium neon laser. Okay. So here what we used iodine stabilized helium neon laser for measuring the meter. Okay. So the path traveled by light in vacuum in this much amount of seconds. You can see how small fraction of second is used to check the length. Okay, so you can see in the 1 second the light can travel this much amount of meter. Okay, 299,792,458 in 1 second light can travel this much amount of meter. In kilometers you will convert it, you will get around 3 lakhs approximately, 3 lakh meter kilometers it can travel within just second. Okay, now the reproducibility is 3 parts in 10 is to 11. So you can see it is highly reliable, which may be compared to measuring Earth's main circumference to the accuracy of about 1 mm, which means if we measure the Earth circumference, there will be only error of 1 mm. Okay, with this new definition of meter, one standard yard will be length of path traveled by light in 0.9144 into this second is equal to in 3 into 10 is to minus 9 second. Now there are certain advantages of wavelength standard. The first advantage is it is not a material standard, and hence it is not influenced by effect of variation of environmental condition like temperature, pressure, humidity, aging. These things will not affect as the wavelength standard is not made of material. Second thing, it need not to be preserved or stored under security, and thus there is no fear of being destroyed as in case of meter or yard. Third thing, it is not subjected to destruction by wear and tear. So there will be no wear and tear. Also, The wavelength standard gives a unit of length which can be produced consistently at all time in all circumstances, at all the places. In other words, it is easily reproducible and thus identical standards are available with the all. This standard is easily available to all standardizing laboratories and industries. Also, there is no problem with the transferring this standard to other standard meter and yard, and it can be used for making comparative measurements of very high accuracy, as the error of reproduction is only of order of 3 parts in 10 raised to 11. Okay, so this is about the all standards. There are two types, but first one was material and second one was the wavelength standard. So this is it for today's lecture. Thank you very much for listening me carefully. Have a nice day.